Welcome to UTC AI Studio, AI powered, creativity fueled. It's not just an upgrade, it's a completely different way of building an AI brain. Today we're going to look at a pretty fascinating new way to build AI that might just completely change how machines see and understand our world. It's called VL-JEPA, and the whole idea is to teach AI to get the concept of something instead of just spitting out words. Let's dive in and see how this thing actually works. But first, you might be asking, why do we even need a new approach? I mean, have you ever wondered why the AI in smart glasses or in robots isn't quite reacting to the world in real time like we do? Well, it's because it's incredibly difficult for an AI to understand what it's seeing and then respond instantly. First up, we'll talk about the current problems with AI vision. Then, we'll introduce this totally new way for AI to learn. We'll get into how it predicts ideas instead of just words. We'll look at the proof, the actual data that shows how much better it is. And finally, we'll explore what this could all mean for the future of AI and our actual lives. Alright, so let's jump right in with the big challenge here. To really understand why this new approach is such a big deal, we first have to understand the limits of the AI we are all using today. You see, most AIs that connect vision and language are what we call vision language models, or VLMs. The AI you're used to it. It's basically a super advanced autocomplete, just predicting the next word in a sentence. You show them an image, they describe it. You ask a question about a video, they give you an answer. But the key thing you got to remember is how they do it. They generate text one little piece at a time, what's called token by token. Think about these two sentences. The light turns off versus the room gets darker. And this whole word by word thing, it causes two massive problems. First, it is just incredibly inefficient to train. The AI must learn not just the core idea, like a dog is chasing a ball, but every single possible way you could say that. That wastes a ton of computing power. And second, building a sentence word by word is just slow. That delay, that latency makes it basically useless for anything that needs an instant reaction, like a robot trying to navigate a busy room. Okay, so this is where our story really gets interesting. To solve these huge problems with cost and speed, researchers at Meta AI came up with a completely new architecture, a whole new way for AI to learn. And here it is, VL-JEPA. It stands for Joint Embedding Predictive Architecture for Vision Language. Yeah, it's a mouthful, I know, but the idea behind it is actually brilliantly simple. What if an AI could actually understand the world without ever using a single word? Here it is. The big change. Instead of just predicting the next word in a sentence, VL-JEPA predicts the idea behind the words. It's working in this abstract space of meaning, what the researchers call a continuous embedding. You can think of it as predicting a coordinate on a map for a whole concept instead of just guessing the next street name. And trust me, this changes everything. So, how does predicting an idea actually work? It sounds kind of out there, I know, but the process is surprisingly logical when you break it down. Let's do that now. Okay, this diagram looks a little intense, but don't worry, the core concept is straightforward. The model takes in something visual like a frame from a video and your question about it. But instead of trying to spit out the exact words for an answer, it's just trying to predict the abstract representation of that answer. It's trying to land in the right neighborhood in that idea space we were just talking about. And it really all boils down to three key steps. First, the X encoder sees the world and basically compresses what it sees into a nice manageable format. Second, the predictor takes that visual data and your question and predicts the meaning, the idea of the answer. And finally, only if we actually need it, a really lightweight Y decoder translates that abstract idea back into words that we can read. You know, here's maybe a simpler way to think about it. A traditional AI is like a writer who's agonizing over every single letter, one by one in order. VL-JEPA is more like a writer who first gets the core idea, the feeling, the concept they want to get across, and then the words just flow naturally from that main point. It's just a much more efficient way to think. And what's so cool about this approach is just how versatile it is, because it's working on this level of ideas. The same core model can be used for a huge variety of different tasks, without needing to be rebuilt from the ground up every single time. And I mean, just look at this range of tasks. It can generate descriptions for images, answer questions about videos, classify objects it's never even seen before, and even find a specific clip just based on a text description. The whole shebang from just one model. Alright, the theory sounds elegant, but does it actually work any better? Is it really smarter, faster, better? Well, let's dig into the proof. Check this out. In a direct head-to-head comparison using the exact same training data, you can see JEPA, that's the blue line, consistently learning faster and getting better results than the traditional VLM in red. I mean, the performance gap is just so clear and it keeps getting wider. And this is where it gets really impressive. This model performs better with half the trainable parameters. Think about parameters as all the little knobs and dials an AI can tweak while it's learning. Having 50% fewer means it's a much smaller, lighter, and way more efficient brain. And then you've got the inference time. The process is decoupled, which means it can understand the scene incredibly fast. And it only takes time turning that understanding into words when it's actually needed. Now, this incredible efficiency unlocks something that traditional models just can't do. It's a feature the researchers call selective decoding, and it's pretty revolutionary. So, because JEPA is always creating this continuous stream of ideas, it can just watch that stream instead of wastefully describing every single frame of a video. It can just wait until the core meaning of the scene actually changes, and only then does it bother to generate any text. It's like the difference between a sports commentator who literally never stops talking and one who only chimes in when something important actually happens on the field. And the impact of this is just massive. This selective approach cuts down the number of times it has to generate text by nearly 3 times, 2.85 times to be exact, while getting the same level of performance. That is an absolute game changer for building AI that can work in real time. Okay, so let's zoom out. What does all this techie stuff, a smarter, faster, more efficient AI actually mean for us, in the real world from a lab to our lives? Well, this isn't just an experiment stuck in a lab. This tech could seriously power the next generation of real-world AI. We are talking about smarter robots that can react instantly to a changing environment. We are talking about wearable AI on smart glasses that can give you truly real-time assistance. Or even security systems that don't just record video but actually understand events as they're happening live. If there's one thing to take away from all this, it's that VL-JEPA represents a more efficient, more intelligent, and way more responsive path forward for artificial intelligence. It's basically a blueprint for an AI that doesn't just process data but can actually understand and act in the physical world right alongside us. But what if that was just a stepping stone? The future of this technology might actually lie beyond Meta. Yann LeCun, the visionary behind this idea, has stepped away from Meta, but he hasn't stepped away from the vision. He's continuing to push this architecture forward independently. And that leaves us with one last fascinating question to think about. For years, we've basically measured how good an AI is by how well it masters language. But maybe, just maybe, AI's next great leap won't be about learning more words, but about finally truly learning the concepts behind them. Thanks for watching utcaistudio, AI-powered, creativity-fueled. I'll see you in the next video where we explore more AI integrations in our daily lives. Till then, as always, keep learning, keep building, and keep creating with AI.